So for the sample, do you use the mean, like, would you write mean is 60 or mean is 59.1?
Sorry, a second.
Which mean do you
So it's about which one? So let's just start with x is normally distributed. So 60. And we want to look at yeah. So we want to see if this is what we get. So that's going to be our H1.
Oh, okay.
I believe. Standard deviation of 3. So what do we do there?
H1 is mu equals 59.1.
I just want to see this for a second. Takes a random sample of 16 and finds the mean amount of juice per carton is 59.1. So in that case, I would say H0 would be that mu is 60, and that perhaps H1 mu is less than 60. Okay. What would we do next?
You have to write like the new mean and like the sample mean. So it's still 60, but the standard deviation is 3 squared over 16. I don't know what's next.
So you just don't remember hypothesis testing stuff, and I'll be honest, I forget this stuff as well. Here's my guess. Distribution, normal, cumulative. What could you do from there?
You can put 60 as the upper limit and the lower limit as just like a very small number.
I'll try 0. Whatever.
And then you can change the mu and the sigma to 60 and 3 squared over 16.
So 3 squared over 16. Minus 60.
Then find. That's 0.5.
0.5. That's very specific. Upper was 60. Oh, hold on. Of course. So if the upper is 60, no. Upper would be 59.1.
Oh.
And did you get an answer there?
0.0548.
And what does that tell us? Or what do we do with that?
Greater than 0.05. So H0 is rejected.
I believe H0 would be accepted. I think it would have to be like 4% or 3% or something.
Oh, okay.
So like not enough evidence.
Oh, okay.
Evidence. Because it's like the opposite would be like degree of certainty. Not enough evidence.
It says test whether or not there is evidence. So.
What was it, sorry?
In the question it says test whether or not there is evidence to offer. So
that's what we did. Let us take a look.
A different answer.
Okay, what did we do here?
They did x is less than 59.1. That's what we did.
So we did 59.1 or less, but where did we? 0.75 squared. Is that the same?
That should be the same, yeah.
Of course, sorry. In our calculator, we just put it in wrong. I put in 3 squared over 16, but actually the standard deviation would just be 3 over 16, I think. Is that right? Ooh, maybe not. What am I doing here? Hold on. Equals.
It
So
should be 0.75. I don't know where they got that from, though.
0.75. So they have 63 squared. Then they do 3 squared over 16. The standard deviation. Of course. We have to do
The
both.
square root of the whole thing.
Yeah, so the variance is like standard deviation squared. So standard deviation is the square root of the variance.
Yeah, I got 0.75 now.
Yeah.
And that's 0.115.
So that's there.
Which is greater than. Yeah, so there's still insufficient evidence.
Yeah. Okay, so that's there.
But I thought since it's less than and the probability is greater than the significance double. Oh wait, no, never mind.
Yeah, so it's like
Time it's greater than, no matter what the hypothesis is, it's always except h naught.
yeah, so it's basically a 5% level of significance is the same as a 95% chance of confidence. Like for it to be just a coincidence, this would happen by coincidence 5% of the time, and so that's the way it works. Grand. So we just have to make sure to square root the whole thing. That's all we have to do. We just didn't square root the top. For the sample mean, that's the Z thing. I think you're going to be okay with this. Let's try it. Or hang on, before we do that. Oops. I just want to see if there's a similar question to what we just did. Let me see this one. Nope. Yeah, let's try this one.
I think it's two-tailed.
Is it?
Yeah.
The mean of the sample is found to be this. Because has it been altered? Is that right?
Yeah.
Yeah, you're right. Oops. I need to look more closely.
Oh, I think I'm. Wait. No.
Fewer than 3 cannot be solved. Yeah, I think this will do. Hopefully.
So you have to do inverse normal first. So that's 1.6449. And then Well, the mean is 5.538. I don't know if that's right.
Um, 5.455.
How?
Yeah, so 5.455. 1, 2, 3, 4, 5. Let's see. A machine produces metal bolts of diameter that's normally distributed standard deviation. So how did you go about this one?
So I use the inverse normal.
Right.
So you just do. So the tail is right because x is greater than 5.62 is 0.05. It says that in the question.
So okay. Probability that D is greater than 5.62 is equal to 5%.
So you put 0.05, but you don't know what the mean is, so you have to use like the normal distribution, like standard deviation is 1 and mean is 0.
Okay.
And then it gives you 1.64485 and so on.
Hold on. Is this under stats?
Yeah, I did it in a different mode though, but
What mode did you do?
there's like when you press menu and then you go to stat. I did it like that, but it's the same thing.
No, I forgot about stats menu. It's better. Distribution, normal, inverse normal. So we have it in standard thing. Tail to the right.
Yeah,
Area 0.05.
yeah,
And I think that's it, is it?
yeah. I got that answer.
Okay.
Then you just put it into the formula z is equal to x minus mu over sigma.
Mm-hmm.
So z is 1.6448, and then x is 5.62. Oh, I think I see what I did wrong.
Go on.
I put sigma wrong. Like, I put the wrong number as sigma. Yeah, I got 5.455 now.
Okay, great. And that is the mean, is it?
Yeah.
Okay.
And then to actually answer the question, you have to find, you just have to find p x is less than 5.1 and p x is greater than 5.6 and then add them together and then do 1 minus whatever it is.
You don't need to do 1 minus, I believe.
No, because it says can be sold. So you do have to do 1 minus.
So in that case, you don't need to find these two and add them together and do 1 minus. Would it not be easier to just do the lower is this, the higher is that?
Oh yeah, you could do that.
Okay, go on, try it.
Got 0.926.
Mm-hmm. 0.26. So it's like 92.6%. Doesn't like it.
No, that's the wrong question.
Sorry. Yes, it does like it. Sorry, I was looking at B.
Yeah.
Okay.
So do you do 1 minus 0.926? And then that fewer than, wait, never mind. That I don't know how to do that question.
It's only 2 marks. Bolts with diameters of less than 5.1 or greater than can't be solved. So you just found the probability was 0.926?
That it can be sold, yeah. So it's in between 0.1 and 5.6.
So then it can't be sold would be 1 minus that.
Yeah.
And it's 12 bolts are chosen. Find the probability that fewer than 3. So I believe it would be binomial in that case.
Oh.
I accidentally gave you a much more challenging question here. So what are the values for this one?
Wait, I don't have on my calculator in binomial CD, I don't have a lower and an upper.
You've graphical one, don't you?
Yeah. It just says data, a variable. Then it says X, which is 0, but just says X.
Press exit. You might have pressed binomial probability distribution by accident.
Yeah. No, it says binomial CD at the top.
So if I press it looks like that, does it?
Yeah, but it's binomial CD.
Let me just go to binomial CD. Try F2 for variable. That's what it should be.
Yeah, it is on a variable. No, why it says that.
Okay, so in that case, you're gonna have to do where you have to do 0, 1, and 2 and add them up.
Or you could just do in like the normal mode. You can do binomial, and you get a list of like the results.
True.
If I can figure out how to do it, yeah, there. You can just do. Wait, we need to find x is less than or equal to 3. So 3, 12. And then 1 minus 0.926, right?
Yeah, and let's use 9256.
Okay. 1 minus. It's 0.991 apparently.
Should not be.
Oh.
What are your things that you're putting in?
I put 3, 12, 0.
Hold on. Fewer than 3. Your calculator automatically does less than or equal to.
Oh. So how do you do fewer than?
Should be 2.
0.9455.
Okay, roughly 0.9455. Let me just hang on. 9454. There we go.
Yeah.
Okay, and Next one. Try that.
I don't understand what the hypothesis would be, like, for that. Oh, would it? Oh, never mind.
Sorry about that. Let's see. Sorry, I'll just be a sec.
I'm not really sure what the hypothesis would be. Would it be 8 zeros p is equal to 5.7?
Sorry about that. Do you produce anything? I don't know. Is this the same mean as before?
No, it's a different question, basically.
Tell me if you get stuck with this one. Oh, so is the mean 5.7 for this, was it?
I think that means it says the sample mean is 5.52.
Okay.
I think I did it wrong because I got 0.997 as the probability.
Might be 1 minus. What's 1 minus?
0.01 probably.
003 or something? Do 1 minus the thing.
1 minus. .002.
2. Okay, how did you go about this one?
So H0 is P is equal to 5.7, I think.
Right.
And then
Hold on. Mu is equal to 5.7.
why is mu equal to 5.7?
Uh,
It says mean diameter. Okay. Oh, okay. I don't know how to do this then. And then
okay.
H1 is mu is less than or equal to 5.7.
Will it not just be less than?
Yeah.
Okay.
So then in the calculator you put 5.52 as the mean and square root of 0.08 over 20 as the standard deviation.
Okay. 5.2 and then root
0.08 over 20.
over 20. Okay.
Yeah, I don't know what to do next.
I think at that point you would just crunch the numbers. Or let's see. So how did we do the previous one? So we did z equals x minus mu over d. And then once we had that, I think it would just be the lower is a low number. So statistics. Oh, and just this exit. Exit. Normal cumulative. The lower is 0. We are saying the upper is 5.52.
I thought that was the sample mean. Why would that be the upper limit?
I'm taking a guess here. But hang on, so if that's 5.52, whether the mean... So I believe we're looking at the probability that that's the mean. Standard deviation is the square root of 0.08 over 20. It's divided by 20. The mean 5.7.
I thought the mean would be 5.52.
I think I got the same as you. 0.002.
Yeah.
0.002. So, oh, I don't know what this is about. Let's see. Mean is that. H1 is less than that. One tail test at 2.5%. That is 5.7. Yeah. And the sample mean is 5.7. Yep. Hang on, 0.017. Let's just check that that's okay. We're square rooting our standard deviation wrong, I think.
How? I did 0.08 and I got over 20 square rooted and it said 0.0632. Oh, it's 0.08 squared. I don't think I did that.
That's what we left out, the squared.
Oh.
And so it's basically just standard deviation over the square of n. Sorry, the square root of n.
Yeah.
And so try changing your value.
5.7 as well. That's wrong.
What's wrong about it?
Oh no, it's right. Okay. I just thought it's like such a small number. Like, how can it be right?
And so what does that tiny number tell you?
Reject 0 and the mean diameter produced is less than 5.7.
That's
I
it.
still don't understand this.
Say it again, sorry.
I still don't understand. Yes.
So I accidentally gave you one that was a bit too tricky. Right one go. So I think what kind of doesn't help is that you're jumping straight into it. It's basically. Do they have a diagram? Do I have a diagram? Let me just try something. Exit. Yeah. So I'll just draw it. Why does it not? Does not shade it in for me? The low. Oh, it's because it's so tiny. I think that's why. You can barely see any shading. And it kind of doesn't help that it's giving me the Z values. So if I was to shade it, what we're doing is we're saying the mean is 5.7. They took a sample and they got a mean of 5.52. And so that's 5.52. My drawing is definitely not to scale. And we are saying, like, what is the probability that if you were to take a random sample, that you would get this as the new mean, and this amount in here is so tiny, and because of that we are rejecting the null hypothesis. So it's normally distributed, and instead of taking we're just saying, like, what is the probability in our sample we got a different mean. Let me just go back to the fundamentals. I should do this other thing first. Yes. Critical region. Yeah, so it's basically just normal distribution. But you are saying, what is the probability that our mean is wrong based on a sample? So if we take a sample and if it shows a different mean, what's the probability that our mean is wrong? And so you'd say, well, what is the probability of getting this other amount? And if the probability of it being random chance is very low, then that would show that our mean is off. Yeah, I won't lie, it's tricky stuff. We missed one. So, all right, we can try two-tailed test if you want.
I don't even get the one-tailed, so.
All right, stick with one-tailed. Hang on. This is used when I disclaim that. Two-tailed test. So that was. Okay, let's try this one.
I got reject 80.
And what level of significance did you get?
I got 4.291 times 10 to the minus 4. Never mind. Oh, they did critical region.
Yes, they did critical region. Critical region for that. Would you be able to do critical region?
Maybe?
Give it a go there.
I don't know how to.
I think you would have to use the other one, the menu one. I don't know what order the numbers go in this.
It should be the same. It should be mean first and then standard deviation.
So mean.
It's saying math error.
I think. See, I don't know what order they're supposed to go in for this one. I'd have to look it up in the book. Binomial cumulative. Oh, so I only need to do 2. 40.
Do 3 if you want like a specific number in the list. Like say you want x is less than or equal to, like x is less than 3, and then you put 3 in, then it gives you like just that probability.
So I think I
don't know how to do normal on this though.
I'll try just without that. Wrong argument size. I have put something in wrong, have I? Is this 16 wrong or something?
No.
Okay, you got the same answer. I'm just not sure how we go about the critical region with that mode in the calculator. Critical region. I suppose I just put them in one by one into the other one, and then just see when I finally get a number that's that one. They're saying critical region 6.384. I think you crushed it. Just want to see, do these? No, they don't all have critical region. It's just that one. Let's see, mean at least 4. Sample. They're all gonna be similar. Alright, let's give it a go.
So you have to use an inverse n to do. got mu is 136.5.
Is there an extra digit?
You can do 136.48. I just wrote 25. Yep.
You do for it.
That would be binomial, the second part.
Yep.
So you would have so you have to do p x is greater than 150 and then find the probability. I got 0.0129. No.
1.29%, yep. And see.
Oh, it's two-tailed.
Do we try it anyway?
Okay. What would the hypotheses be? I'm not really sure.
Usually it'll be equal or not equal if it's two-tailed. Mass and Karm's which numbers?
60.
It would,
would it be mu is equals to 860 and then mu is not equals to 860?
Mu is equal to 860. You're pretty much. It's not just random sample. Yeah, so different shows it's not equal.
Yeah. Then you put in the calculator 875. I got 0.5 as the answer.
Seems wrong. So what? How did you go about it?
And is greater than 875 is 0.5.
Did you put in as your mean 875?
Yeah.
What should you have put in?
860.
Yes.
Okay. gives you 0.247.
And so that's the probability that n is greater than 875.
Yeah.
It's
greater than 0.1. So 80 is accepted.
Hold the phone. A random sample of 15 rats are taken. Sample mean mass. Let's go back. So this was 875 was our lower. Upper is something big. Were we given a new standard deviation? 85. Our mean.
It'd be square root of 85 squared over 15 because it's sample.
Yes. So it should be shift square root bracket 85 squared over 15 squared.
Wouldn't it be just 15? You need to square it again.
Correct. That's what you got?
Yeah.
Looks good. However, like I suppose you could stop there. However, this is two-tailed. So we'd be looking at 5% level of significance.
Mm-hmm.
Would you also have to do something else? Like, let's just see. 24715. That's our one, is it?
Yeah.
Accept H0. Yeah. Okay. So you did A, B, and C all without my help. Any questions about that?
Not really, but it's just like a bit confusing, like which mean you use and like when you use everything.
It's very similar to how you're checking if x is greater than something. Except this time you're just checking. This time x is this new mean.
Okay.
And you just have to convert the standard deviation. Hang on, this is 7, 8, and then these are just more exam questions. This one you don't need to worry about. Let me just check something. Okay, so this looks like it's the most challenging. Let's go for this. And before we do this, hold on. Okay, so I don't have detailed answers, but we'll see how we do.
So the null hypothesis would be mu is equal to 12. And then H1 would be mu is less than 12. I don't know how to do part B.
Determine the maximum mean waiting time surgery could observe in order to reject. So that's just the critical region.
We had a really similar question to part B in our mock, but it was like binomial distribution. I don't know if I did it right though, because I didn't know how to do it.
So I just want to see if I can get the critical region in this mode. I couldn't get it a second ago. Ooh. So the mean is 12. And then takes a sample of 25.
So square root of 3.6 squared over 25.
5. See. Alright, I'm doing it manually. Normal distribution. cumulative. So we want or less. So my lower, tiny, my upper, we'll just have to do this. Oh, hang on. Is this 25 patient times? So we want a critical region. Let me go back. Find the critical region. Machine produces bolts. Standard deviation 50, sure. So they use the Z score. For standardized decoding. Just convert it into its Z score to get the critical region. And then go from there. Let's give this a go. Let's go back to where we were. Okay. So, Z equals X minus mu over sigma. We want to get that. So our mean is 12. Oops. Our X where that's the mean. Oh, we have to get that. So that's our X bar minus 12 over square root 3.6 squared over 25. And this is what significance level?
1%.
Yeah, so 1%. So we find what is the Z score for 1% with these values?
But you have to use inverse normal, but you don't know if the tail is left or right.
So you do both. What area would you use?
0.01.
So because it's two-tailed?
Oh, 0.
Oh, no. Sorry, it's one-tailed, isn't it? Yeah, it's one-tailed.
It's one-tailed. Do 12. 10.3.
What did you put in for? Did you do left? 10?
Yeah, put the sigma as 3.6 squared over 25, square rooted.
Sorry, my mistake. And so what was the answer?
10.325.
So try solving this. So Z is 10.3. Sorry?
That looks really terrible to solve.
Solver.
It's 19.434.
Let's say 19.4. I say 10.3.
I think it's different from critical region. The maximum mean waiting time in order to reject. It's not.
I'd have the maximum mean waiting time. So we would just do what we did. Sorry, we would just do what we did before, and just try different values, I believe. So it would just be the same as this one, and you could just try different values. That's one way to do it. So you could imagine for this one, you could keep changing the sample mean. So you could keep changing the upper in this case until it reached the 1% thing. It would really help if I looked up the calculator, how you put it in to do it in mode 1. So for this one, I can just see it quickly. So what did we... This is shift square root 3.6 squared. And don't forget bracket. Over 25. So that'll just be is it 0.72?
Yeah.
Okay. Distribution, normal cumulative. So the upper is that 11. So that gives us 8. And so there is some way that we would work in reverse. Is that right? It must be inverse somehow, is it? Yeah, it must be inverse. There must be some inverse somehow. I'd have to look it up. 9. And we could see that now. So we know that it would be in between. Hang on, so if I go back to 10. That is 0.0, so 10. So it's between 10 and 11. And I think there's some inverse way of going about it though. I'd have to look it up. Why did they throw this stuff to me? Because it didn't... That's not critical region. Because it didn't come up at any other point. Why do I do this with these one weird questions? Anyway, I think we've got most of it. I'll look into that one. It didn't come up in any other question. I'll make sure.
I think it comes up like really rarely, but it does come up because we had one in Amogha that was like that, and we didn't have to do it.
For binomial, was it?
Yeah, I tried. I don't know if I got it right though.
I'll look in the binomial thing and see. Let me just see this one. Yeah, I'll have to look at that. It has something to do with critical regions, I think. Anyway, how was that for Amogha?
Kind of hard.
Yep, I agree. Anything in particular you want to do next time?
Not I can think of right now.
Okay, and I think
the topics we did this year.
I think after this, oh no, I made this one just for you with all these. Yeah, that's the end of normal distribution anyway. Okay, well if there's anything you can let me know, or I can pick something.
Yeah, you can pick. It's fine.
Alright. Any questions in general?
No.
Alright, well done, Amogha. You did great. I look forward to you.
Hi, I'm here. What happened? I don't know. Can you please sorry, breaking or something?
Have a good week. Good night.
Hey, break in. No? We're not sure if somebody broke in.
Bye.